For both experimental and design work, the methods section form an important part of the scientific process, serving as justification for the validity of the results or design, as well as for any conclusions that can be drawn from the research. This series of videos discusses first, the role of the methods section for experimental and design thesis, and then the methods for organizing this section. Now, for those of you doing an experimental thesis, the significance of the methods section should be straightforward. They document and justify the procedures you've taken to arrive at your results. For those of you doing a design thesis, the role is a little less obvious. But often, in developing or iterating a design, you're doing some form of testing which yields results that motivate design changes, and these methods need to be documented as well. Now, there are three main functions for a methods section in a thesis, the first of which is fairly obvious and straightforward: to allow the experiment to be repeated and for data to be verified. So just as in a normal lab report, the steps and procedures have to be laid out clearly enough to allow for duplication and verification. Even if you're validating or testing the performance of your design, you'll still want to have a very clear set of steps outlining what was actually done so that you can get the same data if you were to run those steps again. In order to do this, however, you'll need to make sure to do certain things. The first of these is to ensure that you're providing enough information and in sufficient detail on all aspects of your methodology. Aspects of your methodology section should include, first, subject or sample choice, including key information about the nature and the preparation of those samples, as well as what is done to those subjects and samples. Second, what observations or measurements were taken and how they were taken, as well as what calculations were performed to those measurements. And third, and finally, key methods for the analysis of that data, including any statistical methods. It's easy to forget or neglect one or more of these categories. A good guideline then is to consider whether or not someone in your field could, with access to appropriate or similar equipment, read these methods and replicate them without having to make too many judgment calls along the way. But this is just the first of the methods section's role. The second is equally important, certainly in terms of the document at least, if not in terms of the research itself. Methods should also help to develop a set of expectations for the results and discussion section that's upcoming. So coming out of the methods section, I should be able to clearly anticipate the results section and probably start to see what the discussion is going to look like and to see what the subject of the research is going to look like. For example, if you have in your methods section a statement like this: we measure apoptosis in cell cultures indirectly, but examine typical changes in morphological properties such as cell shrinkage, condensation of chromatin, and cytoplasm. That creates the expectation that the results will contain measures of cell size and measures of levels of condensation of chromatin and cytoplasm. Being very clear about this in your methods helps prepare the reader to receive certain types of information later on in the thesis or in the article. Your methodology statement might even go further to, for example, describe how the data will be displayed in the results. For example, the dark current and the photocurrent are shown as a function of bias applied at the ITO electrode. That's a pretty technical description of the methods, but it also helps the reader to anticipate and to understand and interpret the graph that would appear later on in the results section of the document, so that when you see this visual later, you can easily understand it. Thirdly, the methods section will also speak to the validity of your data and ultimately of any of your research claims that are generated by the research. This is a very important but often neglected aspect of the methods. It involves taking steps to justify your methodology, including identifying them as a common scientific practice. So for example, a standard Southern blotting method was used to isolate the subject DNA. Or more loosely, we're doing this because everybody else in the field does this. Alternatively, you might use a reference to legitimize your methods. such as methods used for measuring cell adhesion were based on the work of Smith et al. With a citation of, say, 3. Finally, you might also have to provide the logic behind your own methods, an approach that is particularly important for those projects in which the methods are unique. For example, those of you who are developing validation techniques for your design, because those are going to likely be specific to your project and your design approach, or for those of you who are developing methods that are novel, as in the following example. However, since our focus was on longevity rather than the strength of the initial bond, we made the following changes to Smith's methods. After which you would identify the changes and explain how they would help you arrive at measures of longevity. So finally, the methods section also involves identifying and justifying the limitations of the methodology you've designed. And in doing so, the reach of the claims that you can make of your data and your research. So you might have to acknowledge that you were unable to completely control cross-pollination across the samples. And in doing so, you'll have to add qualifiers to your claims, such as likely, probably, with X% of accuracy to make the claims that you can actually make. Essentially, with the discussion here, you're accounting for the potential for error in your methods as you would in a typical lab report.